Hongsak. I'm very pleased to share this session with other distinguished speakers to talk about what should be the research priority on SDG 6 under climate change scenario. So let me share my screen. Okay, I will briefly recap the review of the progress of SDG 6, which is providing clean and safe access to water and sanitation for all. Then I will briefly discuss about what are the major stressors to this SDG 6. Briefly talk about the facts we are facing related to climate change impact on the water security. And then I'll talk about some of the research priorities we should be putting on. And then finally, I'll talk about one of the project we are conducting in the transboundary river basin of the Mekong basin, which is called 3S basin. I think several speakers, they have been, mentioning about this SDG 6, which is ensuring clean water and sanitation for all by 2030. And there are 6 targets, and several agencies, they have been monitoring the progress of these targets related to SDG 6. But last year, UN Water has published a summary report of the progress on SDG 6 against the several indicators, and it mentions clearly that the world is not on track to achieve SDG 6. And I would like to present very briefly what is the status of the progress of these SDG 6 related targets. For example, 2 billion people, they lack safely managed drinking water services until 2022. And globally, the current rate of progress needs to be quadrupled. Still, there are 2.3 billion people, they are living in water-stressed countries, and of which 733 million live in high and critically water-stressed countries. And if you look at those high and critically water-stressed countries, these countries are in Asia-Pacific region and African region. Similarly, in terms of the integrated water resources management, the current rate of progress needs to be doubled to meet the global targets. Until last year, 107 countries are not on track to have sustainably managed water resources by 2030. In this figure, you can see the degree of integrated water resources management implementation, and you can see that majority of the countries, the degree of implementation of water resources management is medium, low to very low. Similarly, you know that 60% of fresh water is a transboundary in nature, and according to the report, it says that only 24 countries reported that all the rivers, lakes, and aquifers that they share with their neighbors are covered by operational arrangement for cooperation. So it needs a lot of effort to bring all countries together to formulate the operational water management plan in terms of the transboundary water resources management. As I mentioned that SDG 6 is not on track, and there are several stressors to achieve the SDG 6, and some of them are rapid population growth, rapid urbanization, and climate change. These are the major stressors of the SDG 6. The United Nations, they have estimated that by the end of this century, there will be 3 billion additional people on the planet. Furthermore, the population is expected to reach by 8.5 billion by 2030. So there is a challenge that how do we achieve this SDG 6, right? Similarly, there is a rapid urbanization, and again, the report mentions that almost 70% of the global population will be in the urban areas. And if you can see in this figure that by 2030, the number of the mega cities and large cities will increase significantly. The climate change, we have been talking since this morning that this is a major stressors to SDG 6. Recently released IPCC Assessment Report 6, it reported that the global warming of 1.5 and 2 degrees centigrade will be exceeded unless deep reduction in carbon dioxide and other greenhouse gas emission occur in the coming decades. An increase of 1.5 to 2 degrees centigrade has been projected by several climate models in the near term, which is 2021 to 2040. And in case of high emission scenario, the temperature is projected to reach to almost 5 degrees centigrade compared to the pre-industrial period. I think this is one of the slides that the keynote speaker in this morning has presented, that COP26 was just over, and if we look at the outcomes of the COP26, I think we are still far to reach this net zero emission by 2050 to limit the temperature increase below 1.5 degrees Celsius. So it means that climate change will be the major stressors to the water sector. And we have already experienced serious impact of climate change and water resources and its consequences. And climate change cascades to the socioeconomic vulnerability through the primary impact, especially on the surface water resources and groundwater resources, and then again the water use sectors like agriculture, hydropower, and other sectors. This figure shows the relative change in annual discharge at 2 degrees Celsius temperature increase compared with the present day under RCP 4.5 scenario. So you can see that there are several countries where the annual discharge will be increasing, where other countries the annual discharge will be decreasing in the future. Similarly, this slide shows the future climate change impacts related to fresh water, which threaten the sustainable development of the affected regions. And if I look at this, statistics of the Bangladesh, that flooded area for annual peak discharge in Bangladesh increases by at least 25% with the global temperature increase of 2 degrees Celsius. Similarly, in other regions, for example, in Brazil, groundwater recharge is expected to decrease by more than 70% by 2050s. Electricity production potential at the existing hydropower station decreases by more than 25% by 2070s. So, looking at these, scenarios, I think we need to spend a lot of efforts on the research, development, and also the capacity building activities at all levels. However, I'm focusing more on the research priorities today, and I want to emphasize that the research priorities should consider the multi-scale nature of the climate change impact and response from the society, ecosystem, and so on. So it should extend from the local level to the global level. At the same time, it's also include the short-term, medium-term, and long-term. And it should focus on the improvement in the monitoring and prediction of the climate change impact assessment on the natural systems and also the man-made system, adaptation to climate change. The research priorities should focus also on the development of the innovative technology and policy that consider the society and environment. Not only that, research priorities should focus from interdisciplinary to the transdisciplinary, because we are always acting, conducting research in silos, but we should extend to not only the science and technology, but also the policy, economics, and so on. At the same time, considering the transboundary nature of the water resources is very, very crucial under this climate change condition. So I would like to highlight some of the research priorities for accelerating this SDG 6 under climate change scenario. So one of the research priorities should focus on monitoring and prediction of the climate change. And there are a lot of advancement in the information and communication technology, and we can use these satellite-based estimated data, use of the artificial intelligence and the big data, improvement in the climate models such as general circulation model, regional climate models, and so on. There are still a lot of uncertainties in the climate change impact and adaptation studies. And the uncertainty comes from the various sources because for the climate change impact and adaptation assessment, we usually use the climate data from the general circulation model. We downscale at the local level, and we use the impact models such as hydrological model, groundwater model, but it brings a lot of uncertainties for the impact assessment and also the adaptation assessment. Therefore, the research priority should focus on what are the sources of the uncertainties. For example, the climate models or climate scenarios or impact assessment model. At the same time, how do we quantify the sources of uncertainties and how to reduce the uncertainties in impact assessment and adaptation? And I think some of the speakers rightly pointed out that the vulnerability assessment should not consider only the top-down approach, but also it should consider the bottom-up approach. For example, including the human dimension, environmental dimension, and also the economic dimension. Similarly, we should not forget the nexus of water, energy, and food. And climate change will be one of the major drivers to impact the water, energy, and food nexus. So how do we quantify water, energy, and food nexus? What is the trade-offs in the water, energy, and food nexus, and how the climate change impact the water, energy, and food nexus? And this would be another priority for the research. Similarly, we talked about the adaptation to climate change, especially in the water sector. But adaptation is very costly, and the outcomes of the adaptation is uncertain. So we should be, working more on the adaptation pathways. And this adaptation pathway is one of the planning approach that addresses the uncertainty and also the challenges of the climate change decision making. It also enables the consideration of the multiple futures, and it allows to explore the robustness and also the flexibility of various options across the multiple futures. So what kind of adaptation options we will formulate? Probably, we can limit that up to certain years, and then again we reevaluate the adaptation options. Then again we implement the adaptation options. So finally, I would like to explain one of the projects that we are conducting in 3S River Basin, which is called Sekong, Srepok, and Sesan River Basin, shared by the three countries, Laos, PDR, Cambodia, and Vietnam. And this project is funded by USAID, and we are planning to wrap up this project very soon. The major objective of this project is how do we optimize the hydropower operation and the fish catch under the climate change scenarios. And there are 4 work packages, and some of the work packages we have already completed. For example, development of the high resolution climate change scenarios, climate change impact assessment on the flows, dam inflows, and fisheries. We have already conducted a couple of capacity building workshops and also the knowledge sharing workshop. And currently we are planning to work on optimization of the hydropower and fisheries production. And this 3S basin is one of the heavily dammed basin, and I think there are more than 29 hydropower projects under operation, and it has altered the hydrology and fisheries production heavily in the downstream countries like Cambodia. So one of the objective of the research is to optimize the hydropower production and fish catch under the climate change scenarios by taking the Srepok River Basin as a case study basin, where we project the future climate, and also we projected the impact of the climate change and hydropower operation on the discharge and fish catch by following the methodology I outlined here. But in terms of the adaptation, we want to explore how to regulate the reservoir of the hydropower project so that hydropower production is still same or increased in the future, and also the fish catch or fisheries production in the downstream is also the same or increased in the future. So we are planning for this multi-objective optimization through genetic algorithm approach. These are some of the results of climate change impact assessment on hydrology, and we have projected the impact for near future and mid future. And if you look at this monthly average discharge compared to the baseline condition, which are shown here as a dotted line, and the future discharge at the solid line, overall, the flow in the future is projected to increase, but there is still variability in the monthly flow. We have also projected the impact of climate change on the fish catch, which includes the impact of climate change and hydrology. And we try to see what is the relation between the flow and the fish catch in the downstream station in the Cambodia. And we found that in future, the fish catch will be increasing. On an average, it will be increasing, but few months, it is projected that the fish catch will be decreasing. We have also simulated the climate change impact on the hydropower production, and we compared the hydropower production with the same reservoir regulations in the future under the future climatic conditions. And we found that the future hydropower production under the climate change will be decreasing in future. And if you look at these results from the ensemble of the climate models, there is still a decrease of 10 to 20% in various hydropower projects. So now we want to optimize the hydropower production and also the fish catch by considering how do we regulate the reservoir in the future. So we have developed these objective functions with the decision variables, turbine flow and spill flow. So we think that this discharge to the turbine and also the spillway, probably the amount of water available for the fish in the downstream can be regulated through the reservoir under the climate change conditions. So currently we are working on this optimization and hope to finalize it very soon. So with this, I would like to conclude my presentation by highlighting that climate change continue to be a major stressor to the SDG 6, and the research priorities should focus on multi-scale nature of the climate change impact and adaptation. And also it's very, very important that we accelerate the adaptation to reduce the water insecurity because of climate change. And thank you very much, Dr. Pongsa.